Some equations can look difficult when you first meet them, but in this lesson, you will learn how to handle them in a much easier way. You will learn how to break them into clear steps, how to work forwards, and how to work backwards. Stay with it until the end, because this method will make the whole topic feel much more manageable. Let us begin with a simple machine idea. Something goes in, a set of steps happens, something new comes out. Think about making a burger. At first, there is only the bottom bun. One step adds the patty. The next step adds cheese. The next step adds salad. The final step adds the top bun. The order matters. Bottom bun, patty, cheese, salad, top bun. That is a machine process. Now run the same process backwards. To undo the burger, remove the top bun first, then remove the salad, then remove the cheese, then remove the patty, and we are back to the bottom bun. So the key idea is this. Forwards means doing the steps in order. Backwards means undoing the steps in the reverse order. Now we move into number machines. The first machine has 2 steps. Multiply by 3, then add 2. Start with 1. 1 multiplied by 3 is 3. 3 plus 2 is 5, so 1 becomes 5. Start with 4. 4 multiplied by 3 is 12. 12 plus 2 is 14, so 4 becomes 14. Start with 7. 7 multiplied by 3 is 21. 21 plus 2 is 23, so 7 becomes 23. The table keeps x as the input and y as the output. When x is 1, y is 5. When x is 4, y is 14. When x is 7, y is 23. The same rule can be written as boxes. X goes through multiply by 3. Then it goes through add 2. The result is y. Now reverse the first machine. The last forward step was add 2, so the first backward step is subtract 2. The earlier forward step was multiply by 3, so the next backward step is divide by 3. Start from 5. 5 subtract 2 is 3. 3 divided by 3 is 1. Start from 14. 14 subtract 2 is 12. 12 divided by 3 is 4. Start from 23. 23 subtract 2 is 21. 21 divided by 3 is 7. The same table still keeps x on the left and y on the right. Now we move to the second number machine. This time the steps are divide by 4, then subtract 3. Start with 16. 16 divided by 4 is 4. 4 subtract 3 is 1, so 16 becomes 1. Start with 20. 20 divided by 4 is 5. 5 subtract 3 is 2, so 20 becomes 2. Start with 36. 36 divided by 4 is 9. 9 subtract 3 is 6, so 36 becomes 6. The table records the pairs. When x is 16, y is 1. When x is 20, y is 2. When x is 36, y is 6. Now write the same rule as boxes. X goes through divide by 4. Then it goes through subtract 3. The result is y. To reverse it, undo the final operation first. Subtract 3 is undone by add 3. Divide by 4 is undone by multiply by 4. Start from 1. 1 plus 3 is 4. 4 multiplied by 4 is 16. Start from 2. 2 plus 3 is 5. 5 multiplied by 4 is 20. Start from 6. 6 plus 3 is 9. 9 multiplied by 4 is 36. The input and output columns stay in the same order. X first, then Y. Now we move to the third number machine. This one has 3 steps. Square the input. Multiply by 2. Add 3. Start with 2. 2 squared is 4. 4 multiplied by 2 is 8. 8 plus 3 is 11. So 2 becomes 11. Start with 3. 3 squared is 9. 9 multiplied by 2 is 18. 18 plus 3 is 21. So 3 becomes 21. Start with 5. 5 squared is 25. 25 multiplied by 2 is 50. 50 plus 3 is 53. So 5 becomes 53. The table gives the pairs. When x is 2, y is 11. When x is 3, y is 21. When x is 5, y is 53. Now reverse the 3-step machine. Add 3 is undone by subtract 3. Multiply by 2 is undone by divide by 2. Squaring is undone by taking the square root. Start from 11. 11 subtract 3 is 8. 8 divided by 2 is 4. The square root of 4 is 2. Start from 21. 21 subtract 3 is 18. 18 divided by 2 is 9. The square root of 9 is 3. Start from 53. 53 subtract 3 is 50. 50 divided by 2 is 25. The square root of 25 is 5. Now we move from numbers to algebra. The letter X can stand for many possible inputs. It could be -10, -5, -2, 0, 1, 2, 3, 4, 7, 10, 15, 25, 1/2, or 100. After all of those possible values, we return to X. So X is a placeholder for the input. Use the first algebra machine. Start with X. Multiplying by 3 gives 3x. Adding 2 gives 3x plus 2. So the output is y. Y equals 3x plus 2. Now reverse that relationship. Start with y. Undo add 2 by subtracting 2. That gives y minus 2. Undo multiply by 3 by dividing by 3. So x equals y minus 2 all over 3. Use the second algebra machine. Start with x. Dividing by 4 gives x over 4. Subtracting 3 gives x over 4 minus 3. So y equals x over 4 minus 3. Now reverse it. Start with y. Undo subtract 3 by adding 3. That gives y plus 3. Undo divide by 4 by multiplying by 4. So x equals 4 times the bracket y plus 3. Use the third algebra machine. Start with x. Squaring gives x squared. Multiplying by 2 gives 2x squared. Adding 3 gives 2x squared plus 3. So y equals 2x squared plus 3. Now reverse it. Start with y. Undo add 3 by subtracting 3. That gives y minus 3. Undo multiply by 2 by dividing by 2. That gives the fraction y minus 3 over 2. Undo squaring by taking the square root. So x equals the square root of the whole fraction y minus 3 over 2. Now comes an important point. The order of the operations changes the equation. Use the same 3 operations. Square, multiply by 2, add 3. If we square first, then multiply by 2, then add 3, the equation is y equals 2x squared plus 3. If we multiply by 2 first, then square, then add 3. The equation becomes equals bracket 2x bracket squared plus 3. If we multiply by 2 first, then add 3, then square the whole result. The equation becomes equals bracket 2x plus 3 bracket squared. Same operations, different order, different equation. Now repeat the same idea with cubing. If we cube first, then multiply by 2, then add 3, the equation is y equals 2x cubed plus 3. If we multiply by 2 first, then cube, then add 3, the equation becomes y equals bracket 2x bracket cubed plus 3. If we multiply by 2 first, then add 3, then cube the whole result. The equation becomes y equals bracket 2x plus 3 bracket cubed. Again, the operations are the same. The order is different, so the equation is different. Now we build a machine from an equation. Start with y equals 4x squared plus 3. To decide the machine steps, use BIDMAS, the order of operations, brackets, indices, division, multiplication, addition, subtraction. In this equation, the index comes first, so square x first. Then comes multiplication, so multiply by 4. Then comes addition, so add 3. The machine is x, then square, then multiply by 4, then add 3. That matches y equals 4x squared plus 3. Now build a second machine from a different equation. This time the equation's y equals the square root of the whole fraction x plus 4 over 9. The fraction is inside the square root, so the fraction must be made before the square root is applied. Begin with the grouped part, x plus 4. So the first step is add 4. Then make the fraction by dividing by 9. Then take the square root of the whole result. The machine is x. Then add 4, then divide by 9, then take the square root. That matches y equals the square root of the whole fraction x plus 4 over 9. Now bring the whole idea together. Use the first rule again. Multiply by 3, then add 2. So y equals 3x plus 2. Several inputs can pass through the same rule. 1 becomes 5, 2 becomes 8, 4 becomes 14, 7 becomes 23, 10 becomes 32. Each input has one matching output. Now reverse the rule. The forward equation is y equals 3x plus 2. The backward equation is x equals y minus 2 all over 3. 5 goes back to 1, 8 goes back to 2, 14 goes back to 4, 23 goes back to 7, 32 goes back to 10. That is the full method. Forwards, do the operations in order. Backwards, undo the operations in reverse order. When x goes in, y comes out. When y is known, the inverse machine takes us back to x.